All right, here are going to be your ratio notes for your the first portion of notes 4a.1. We're just going to review what ratios are and what to do with them. We're going to review that a ratio is going to be a comparison of two, we'll put in parentheses, or more quantities. Quantities meaning number of things. There are three different ways that we represent a ratio. We can do it in fraction form, saying A over B. We can do it actually saying A, the word 2, and then B. And then we can also put a colon between A and B. When we do our proportions with this unit, we will be using the fraction form. Okay. We also need to be super careful because we need to make sure that once we set up a ratio, we need to remember that some ratios can be simplified. This is going to be a very important thing, so I want you to highlight that. Now, the four examples we have are dealing with these right here, the different kinds of musical instruments that this music store has, and I'm going to be color coordinating just to make it easier for you guys to see. We're going to have 40 trumpets, we're going to have 39 clarinets, we will have 24 violins, 51 flutes, and 16 trombones. Okay, so first thing we're going to do is our ratio of trumpets to violins. Now, again, we can set it up several different ways, as we see up here. Okay, I'm going to be setting them up in both the first and the last. Okay, because when we talk about similarity ratio later on, similarity ratio is generally written with the colon. And whenever we deal with scale factor and proportions, we will be using the fraction. Now, anytime that we write it, we need to make sure that the first thing that's written is the first object, or the first one that comes. So we have trumpets to violins. So if we're going to do trumpets to violins, 40 trumpets needs to go first, and so we'll have trumpets to violins. See, I read for my violins, and we have 24 violins. Okay, again, remembering that we need to simplify this, and each one of these can be divided by 8, giving us a total of 5 to 3. And writing in fraction form, same thing, we just do the 40 over 24, dividing both by 8 to simplify that fraction, and we would have 5 over 3. Okay, so these are two different forms we'll see. Your flutes to clarinets, we have 51 flutes, and we have 39 clarinets. So flutes come first, so we're going to write that first. Both of these can be divided by 3, so we will simplify this to 17 to 13. Fraction form then, the first one of flutes goes on top, the second one of clarinets will go on bottom. Again, simplifying by dividing by 3, we come to the total of 17 over 13. Next, we have trombones to trumpets. So we have trombones, 16. I'm going to go ahead and set both of them up since I'm using different colors. Trombones to our trumpets, blue, which would have been 40. I'm going to use my black pen to put the colon here, fraction bar here. Both of these can be divided by 8. So we want to simplify it to 2 to 5. That would be the ratio. Over here, fraction form, oops, it should be 8 divided by 8, and we get 2 over 5. The next one is going to show us violins to total instruments. Okay, so our violins I have in red, so we're going to have 24 and we're going to have this to the total instruments. So we need to make sure we come over here and we count up all of these, we add them. We have 40 trumpets, plus 39 clarinets, plus 24 violins, plus 51 flutes, plus your 16 trombones. We add all of these up, we have a total of 170 instruments. So this would be 24 to 170, okay? Both of these can be divided by 2, giving us our ratio of 12 to 85. And again, if I do this in fraction form, I have 24 over the 170, dividing both by 2. So I'll have 12 over 85. Okay, so we'll work on some practice problems on the inside now. And we're going to be using our ratios to find angles and sides. Okay, so the first example we have here says the ratio of two complementary angles is 3 to 7. So what this means is the 3 is going to go with one angle and the 7 is going to go to another angle. We have to add them to equal. The complementary here is going to remind us of 90 degrees. Okay, complementary angles are 90 degrees. Now we don't know what the scale factor is here, how to get to our angle measurement, so we're just going to plug in an x. So if we take 3 times x plus 7 times x, this should equal out to 90 degrees. We do want to find the measure of both angles, so once we figure out what x is, we do have to substitute it in. So we'll combine our like terms. 10x equals 90. Divide both sides. X is going to equal 9. So then you take your first angle and you plug in the 9. One angle measurement is going to be 27 degrees. The other one, take 7, plug in 9. We're going to get 63 degrees. So these would be the measurements of the angles, and we can always double check and say 27 plus 63 does come out to 90, so we can check our work as well. So that's when we're dealing with our angles with complementary. The next we're going to see ratio of two supplementary angles. Okay, so your supplementary angles are going to be that magic number of 180 degrees. So we'll do the exact same thing, it's just this time we're setting it equal to 180. So we'll take that 4 and we attach that x to it. We're going to add, now we don't need to put a 1 in front of this x, so we just put an x, and that equals 180. We get 5x equals 180. Divide both sides by 5. X comes out to 36. So again, we plug in 4 times this 36. It's going to give us 144 degrees. And the other x is just simply 36. So we have 36 degrees. And these will be our two angle measurements. Again, we could check our work. If we add them together, we get 180 degrees. Okay. The next one is talking about the ratio of measures of two complementary angles is 7 to 8. What is the measure of the smaller angle? So we need to look at the smaller number in the ratio of 7 to 8. So we're just going to be plugging into the 7x in the end. Okay? So we have our 7x plus our 8x, and we are looking at complementary, back to 90 degrees. So we have 15x, combine our like terms, equals 90. We divide both sides. X will come out to 4. So all we need is that smaller angle. So we take our 7, we replace 4, and we find out the smaller angle is 28 degrees. Okay? The next one is going to get a little detailed here. Here we're looking at the ratio of the measure of the vertex angle to the base angle of an isosceles triangle is 8 to 5. So the first thing we need to see here is our vertex angle comes first, so that's going to be the first number. And then we have our base angle, which is second, so that will go with the 5. We want to know what is the measure of the vertex angle, so we're only going to plug in for the 8. Now what we need to remember with the vertex and base angles, we're looking at an isosceles triangle, where here's our vertex angle, and down here are going to be our base angles. Okay? So up here, 8 is going to represent the vertex angle, and 5 is going to represent the base angle. But we need to remember this is only one base angle. Okay? So when we go and we add in these x's that we've done on these other ones, we need to remember that we do have this 8 for our vertex angle, so we have the 8x. But that 5, we need to remember that we can set these all equal to 180 because we have 3 angles, but we have to include both base angles. And here, 5 is only representing one of the base angles, so we need to make sure that we add in both base angles. That's why we have two 5x's. And we set this all equal to 180 for our triangle sum theorem. When we add all three of our like terms together, we get 18x. We set that equal to 180. Solve for x. X will equal 10. Now we did want the vertex angle, which was the 8. So we take the 8x and we substitute in 10. We find out our vertex angle is 80 degrees. Okay?